Okay. So what we studied? Nth order LDE with constant coefficient. Okay. Phi of dy equal to f of x. What is the general solution? General solution is y equal to y of c plus y of p. Okay. First part is complementary function, and we know the four formulas. Okay, corresponding to the complementary function. Second part is to find a particular integral. Okay. So in today's lecture, our aim is to understand the concept of a particular integral and how we can find a particular integral using one of the method, general method. Okay, clear? I am audible now?
Yes, sir.
Okay. Let me continue. So let me start with few formulas of integration. Okay, so formulas of integration. These formulas are required when we'll study the general method. Therefore, we are writing them here only. Right? Substitution method. Substitution method. Okay. So write first formula. Write this as A. Integration of f dash of x divided by f of x dx. Yes, who remember this formula? We use this formula in unit number 1, M2. While solving the differential equation, we use this formula. Okay, so derivative of denominator is in numerator. Therefore, what is the integration? Log of denominator plus some constant. Hope everyone remember these formulas. Okay. And we studied this formula also, f dash of x divided by root of f of x dx. Yes. What is the answer? 2
f of
Under root
x.
f of x.
f of x. Very good. Okay. Next, f of x raised to n. F dash of x dx. Yes. What is the integration? F of x raised to n plus
And
1 divided by n plus 1. Okay. Then fourth formula, e raised to f of x. Important formula. F dash of x dx. What is the integration? E raised to f of x. Yes. Fifth formula, e raised to x. Understand? Huh? F of x plus f dash of x. Yes. Who remember this formula? What is the
E to the
integration?
power x into f of x.
x f
Very
of x.
good. E raised to x f of x. Very good. Absolutely. Then let me change the page. Let me write on the next page. So today is 31st. Yes, right. B part. Integration. By parts. U as it is integration of v minus u dash. Integration of v. Multiplication of these two and then integration. Okay. And how to choose the first function? First function selected using ILATE rule. Okay, I is inverse trigonometric function, L is logarithmic function. These are the most difficult functions to be integrated. Okay, A is the algebraic. Yes, T is the trigonometric, and E is the exponential function. Exponential function and trigonometric function are the most simple functions to be integrated. Then Bernoulli's law. Yes, what the Bernoulli's law is? U as it is integration of V minus U dash integration of V twice plus U double dash integration of V thrice and so on. Okay. How the function U is to be selected? U derivative of, yes, anyone remember? Function becomes zero. Then only we can use Bernoulli's law. The derivative of one of the functions should become zero. Then only we have to use Bernoulli's law, and in that case, U will be the function whose derivative becomes zero. Okay, we know this formula is very well. Next, I think you know all these things very well. Integration by partial fraction. Integration of rational functions. Rational function means function which is written like this, f of x divided by g of x. So first is, we know this, f dash of x divided by f of x. Whenever derivative of denominator is in numerator, log of f of x. But many times it is not so. So use of partial fraction. Hope everyone know this, partial fraction. For example, we want to integrate 1 upon x square minus 3x plus 2 dx. That may be written as 1 upon x minus 1, x minus 2. Then we can find partial fractions, a divided by x minus 1 plus b divided by x minus 2. And then we can integrate. Please do the remaining part yourself. Okay. Many times it is not possible to find partial fraction. Then perfect square method is used. Okay. For example, say our aim is to integrate this x square plus 2x plus 2. Right. Now we cannot find the factors. Since roots will be imaginary, therefore. So what we have to do? We have to do it in this way: x square plus 2x plus 1 plus 1. Isn't it? And it is 1 upon x plus 1 whole square plus 1 dx. And then we can integrate it. Yes, anyone? How to integrate this? How we can integrate this? Integration is 1 upon a. Good. Tan inverse of x by a. Right. So I have used this formula. 1 upon x square plus a square dx. What is integration? 1 upon a tan inverse of x by a. I use this formula. So these are the different methods to integrate the rational function. Okay. Hope everyone know the logarithmic and exponential formulas. Okay. So I'm not going into details of those formulas. They are very well known to us. Clear? Let me go through the next part. Okay. So hope you might have understood all the formulas. Remember them. Try to remember these formulas. Let me start with the particular integral part. Right. So two parts are there of the general solution. One is complementary function, that already we studied. Second is particular integral. Okay. Hope you remember how we obtained the complementary function. So write with me. Consider nth order linear differential equation with constant coefficient as phi of dy equal to f of x. Say I want to find y from here. So what I have to do? I have to operate. Okay, so see, I'm writing like this. Operate 1 upon phi of d on both sides. Okay, so 1 upon phi of d operated on phi of dy equal to 1 upon phi of d operated on f of x. Should
Sir,
be written.
CC म्हणजे
Constant coefficient.
okay sir.
So this phi of d will cancel. What will remain? Y, in fact, y of p. Again, it is notation. So you don't ask me how y becomes y of p. Notation only. Okay. So this is what we want to understand. Okay. Now we're done. There are three methods to find pi. What is pi? Mention it here. Particular integral, or we may write just pi. Okay, instead of writing dot, if you're writing pi, that is okay. They are right. General method, shortcut method, method of variation of parameters. Okay, so done. One, general method. Write one general method. Yes, now below that I don't to solve the differential equation dy by dx plus my equal to f of x. So time being we are considering first order differential equation. Okay. So write down. It is how we can write this equation. D plus my equal to f of x. Then general solution is, what is general solution? Y equal to y of c plus y of p. First part complementary function. Okay. And for that auxiliary equation is required, right now? And what is the auxiliary equation? D plus m equal to 0. That is d equal to minus m. We are considering that m is a real number. Okay, and therefore what is the y of c? Y of c equal to c1 e raised to minus mx. Isn't it? This we know very well. Okay. Now let me solve the differential equation by whatever we studied in M2. Okay. So this is what we know in M3. So afterwards I'll compare this. I'll substitute the solution here. Here, let me substitute it here on the next page. Let me do it on the next page. Can I change the page? Have you written up to this step? Again, it is not compulsory to write the explanation. You can skip the explanation part. At the end, I'll write 2-3 formulas. They are important. So usually, since we have time at this moment, therefore I'm explaining how the formula is obtained. Usually, we don't get time to explain all these things. And again, as an engineer, it is not expected. But it is always better if you understand from where we are getting this formula. Okay. So please let me continue. So from equation 2, y equal to y of c plus y of p, that is y equal to c1 e raised to minus mx, this is known to us, plus y of p. This is general solution that we obtain by whatever we studied in the M3. Okay. Now let me use the M2 method. In fact, it is not M2 method. It is the solution of linear differential equation of first order first degree differential equation. So dy by dx plus my equal to f of x. It is linear differential equation in y. So it is of this form. Hope you remember. Dy by dx plus py equal to q. आ रहा है ना सबको याद? So what is p here? P is equal to m, and what the q is f of x. Right? Once p and q are known, we can find integrating factor, and it is e raised to integration of p dx. So e raised to integration of m dx. So e raised to mx. This is integrating factor. Now we want to find a general solution. So y integrating factor equal to integrating factor into q dx plus some constant, say c. So y into e raised to mx equal to e raised to mx into q. Q is f of x dx plus some constant. Okay, let me multiply by e raised to, our aim is to find y, na? So multiply by e raised to minus mx. So y equal to e raised to minus mx, and e raised to mx f of x dx into c e raised to minus mx. This is the general solution. Equation number 4. So this is the solution that we obtained by the whatever we studied in M3, and this is whatever we studied in M2. So both of them are general solution of the same differential equation. So comparing 3 and 4. Yes, compare 3 and 4. See y here. Here also we have y. Okay. Here e raised to minus mx. Some constant, whether it is c or c1 doesn't matter. I think you this much mathematics now we understand. So both are solutions. Okay. Both are same. Sorry. So what is y of p? Y of p is e raised to minus mx. E raised to plus mx f of x dx. Then hope you remember. Right, you might have understood this. Hope you remember before some time we have written this. I'll write it here. Phi of dy equal to f of x. Then what is particular integral? Y of p equal to 1 upon phi of d f of x. Right now? So for the given differential equation, the differential equation is like this. D plus, try to understand this, d plus my equal to f of x. So what will be the complementary function? Y of p will be 1 upon d plus m operated on f of x. That is, ये समझ में आ रहा है ना आपको कहाँ से आ रहा है? ये मैंने at the starting we have written all these things. Okay, phi of dy equal to f of x. So we operated 1 upon phi of d. It might be there on your previous page. Okay. Then y of p equal to 1 upon phi of d operated on f of x. Right? That I have used for above differential equation. The above differential equation was d plus my equal to f of x. So what will be y of p? Operating 1 upon d plus m on f of x. That is, see now how I am writing it. Y of p equal to 1 upon d plus m operated on f of x. That is equal to e raised to minus mx, right? See, plus m here, that become e raised to minus mx. Inside the integral e raised to plus mx, and to be operated on f of x dx. This is the formula to find the particular integral. आ रहा है सबको समझ में? Everyone is getting this? Okay. So any doubt here? Have you written these things? If you want, can I go through the next page? So at the end, I'll write 2, 3, 4 minutes, and then we'll go through the examples. समझ लगा है? समझ में आ गया आपको? Can I go through the next part?
Yes, sir.
कितने कितने स्टूडेंट आ गए अभी? Only 31. What about others? Not interested in maths lecture? Okay. Let me go through it. So at the end, these are the formulas that we have to remember. Okay. So formulas.
Sir, page.
Oh, sorry. Formulas, they are like this. The 1 upon d plus m operated on f of x. What is it? Plus m converted into minus m. Inside the integral, e raised to plus mx and f of x dx. Now say I want to use formula for 1 upon d minus m. Yes, what will be the formula? So e raised to plus mx, e raised to minus mx, f of x dx. These are the two formulas. Okay. Then note, say I want to operate 1 upon d plus 2 and d minus 3 on some function. What are the different options? Okay. So 1, operate 1 upon d minus 3 first and then 1 upon d plus 2. How to do this? We'll understand through few examples. Okay. Second, now what we can do, we can reverse the order. Operate 1 upon d plus 2 first and then 1 upon d minus 3. Right. Now question may be how to decide whether we have to operate 1 upon d minus 3 first or d plus 2 first. It depends upon few tricks are there, and I have no doubt it depends upon the practice. Okay, we'll understand this while solving the examples. Third, right, we can operate 1 upon d plus 2 and 1 upon d minus 3 simultaneously. How? Using, yes, partial fraction. Partial fraction everyone know ना? Partial fraction हमें find करने पड़ेंगे इसके, and then we can operate both of them together. Okay, these are the three ways, these are the three different methods. Okay, now let me go through the example. We understood the theory, what the formulas are there. So time being, at least you remember about two formulas, these two formulas, formula number 1, formula number 2, and then remember the note so that we'll be able to solve the examples. Okay, so solve d square plus 3d plus 2y equal to e raised to x, e raised to x. Okay, so general solution is y equal to y of c plus y of p. Okay, first part, complementary function d square plus 3d plus 2 equal to 0. D plus 2, d plus 1, isn't it? So roots are minus 2 and minus 1, and therefore complementary function is c1 e raised to minus 2x, c2 e raised to minus x. This is the complementary function. Okay, this is very well known to us. You can change the order of minus x and e raised to minus x and e raised to minus 2x. You can change the order of roots, no any problem. Sure. Can I change the page? Can I go through the next page? Yes, can I go through the next page?
Yes, sir.
Okay.
Sir,
Yes.
म्हणजे आतापर्यंत आपण जेवढं सगळं स्टार्टिंग पासून आतापर्यंत केलं ते फक्त कॉम्प्लिमेंटरी
Correct. Absolutely. Where the right hand side we considered as 0.
हा ते ऑक्झिलरी इक्वेशन
Correct. Absolutely.
ह्या कॉम्प्लिमेंटरी फंक्शनला जर पर्टिक्युलर इंटिग्रलनं ऍड केलं तर मग हे पूर्ण फंक्शन बनतं ना.
Correct. General solution. We'll get the general solution. Correct. Okay. Can I continue? Okay. Right. Next. Second part. PI. Particular integral. What is particular integral? Y of p equal to, this is the differential equation, d square plus 3d plus 2y equal to e raised to x. Okay, I'll take this operator to other side. So this will become 1 upon d square plus 3d plus 2 to be operated on e raised to x. That will become 1 upon d plus 2 d plus 1 operated on e raised to x. Now see, I'm writing few things here. Okay, let me continue time being. I'll use this formula using 1 upon d plus m operated on f of x. Yes, what is the formula? Plus m will be converted into minus m. E raised to plus mx inside, and then whatever the function f of x is. So let me do it in this way. 1 upon d plus 2 as it is. I'll operate 1 upon d plus 1 first. At this moment, question may be why I am operating d plus 1. Why not d plus 2? Okay, I'll explain it, but time being, let me give some time. Okay, so y of p equal to, keep 1 upon d plus 2 as it is, right? So as in this case, plus m is converted into minus m. Here we have plus 1, that will be converted into minus 1. Inside the integral, e raised to minus x will become e raised to plus x, and whatever the function is, e raised to x dx. Right, now we want to integrate this. Yes, what is the formula? Yes, what is corresponding formula? Hope you remember this. E raised to f of x, f dash of x dx. What the integral is? E raised to f of x. What is f of x here? Yes, what is f of x here? Are f of x kya hai? We cannot integrate e raised to x directly, huh? So this whole e raised to x, the power of e, that is considered as f of x. Then what is f dash of x? E raised to x itself, and that is here. Okay, so what is the value of integral? Like this, see, 1 upon d plus 2 as it is. E raised to minus x outside the integral as it is. Value of integral is e raised to f of x. So e raised to x. Clear? Now you might have understood why we operated d plus 1. Since plus 1, d plus 1, this plus 1 will give e raised to x inside the integral. And the given function f of x also contain e raised to x. Therefore, टाइम से समझते हैं मैं क्या बोल रहा हूं, समझ में आ रहा है आपको? Why we operated d plus 1 upon d plus 1 first? Since this plus 1 will give e raised to minus x outside, and inside the integral e raised to plus x, and the given function contain e raised to x. Therefore, whereas if we operate d plus 2 na, we might have got e raised to 2x here. यहाँ पे भी e raised to 2x मिला होता तो थोड़ा सा इंटीग्रेशन डिफिकल्ट हो जाता. I am not saying it was not possible. Though integral is possible only, but थोड़ा सा difficult हो जाता. ठीक है, इसलिए. Now let me use this formula. I am saying this formula of the general method once again. Okay, so plus 2 will be now e raised to minus 2x, isn't it? Then inside the integral e raised to plus 2x into whatever the function on which we want to operate this. So it is e raised to minus x, e raised to x. Hope everyone is getting this, huh? So e raised to minus 2x, or ये simplify करके, if you simplify these two, that is e raised to x, and then e raised to x. Above we have integrated this, and we know integral of this. Okay, so let me write it directly. यहाँ पे हमने किया है, देखो यहाँ पे है, और उसका आंसर भी हमें पता है, ये है आंसर, है ना। सो e raised to x, ये आ गया आपका पर्टिकुलर इंटीग्रल। आ रहा है सबको समझ में? गेटिंग एवरीवन? ओके, नाउ लेट मी कंबाइन द particular integral and complementary function. So from 1, 2 and 3, general solution is y equal to c1 e raised to काय होतं सांगा मला, -2x plus c2 e raised to -x plus e raised to -2x e raised to x. जेते हैं, समझते सर्वांना? समझ में आ रहा है सबको? हाउ वी ऑब्टेन द पर्टिकुलर इंटीग्रल? एवरीवन इज गेटिंग दिस? आ रहा है नहीं सबको समझ में? अरे कुछ तो बोलो। आवाज नहीं है मेरे, आवाज बोला। श्रेयस आवाज येत नाही तुझं, बोल परत एकदा।
थर्ड इक्वेशनचं सेकंड लास्ट स्टेप.
सेकंड लास्ट स्टेप म्हणजे ही का? दिस वन? हा, अंडरस्टूड और नॉट? हा हा,
केलाय ना थर्ड इक्वेशन, त्याचं लेफ्ट साइड.
लेफ्ट साइड, हा हा,
e raised to x multiplied by e raised to x.
हा करेक्ट.
तर इंटिग्रेशनच्या आतमधलं जे e raised to x तो कुठं गेला ते समजलं ना?
अरे हे ऐड कर की राजा, हे दोन ऐड कर रे. What will be multiplication of these two? What is e raised to a into e raised to b? असं असतं ना? e raised to x येईल की नाही?
हा हो सर.
Okay. And then value of this integral is known to us. Above we have integrated it. इथे integrate केले ते. Clear or not?
Yes sir.
Okay, let me continue. See, while defining the particular integral, I think in first or second lecture, I told you that particular integral is obtained from complementary function. याद है क्या आपको? Particular integral is obtained from complementary function by assigning particular values to arbitrary constant. ऐसे कुछ मैंने बताया था आपको, है ना?
Yes,
तो उसको
sir.
समझते, हाँ उसको समझते हैं. Let me change the page. So for the previous example, let me write the example: d square plus 3d plus 2y equal to e raised to x. What the complementary function is? c1 e raised to -2x plus c2 e raised to -x. Whereas what the particular integral is? e raised to -2x and e raised to x. ऐसे आ गया ना फाइनल आंसर हमारा? Okay, so compare, you just compare these two and you might find that comparing, right, what the c1 is e raised to x. What the c2 is? 0. Okay, particular values are given to c1 and c2 in the complementary function to get the particular integral. Okay, clear? आ गया सबको समझ में? Any doubt here? Can I proceed now? क्या हम आगे जा सकते हैं? अरे कुछ तो बोलो, नहीं जाना है? I am not audible.
तर c1 ला e raised to x कसं केलं?
हे कम्पेअर कर किती आहे एवढं कळत नाही. हे कम्पेअर करायचं दोन. अरे हे e raised to minus 2x e raised to minus 2x उसको कैंसिल करो, क्या आएगा? c1 e raised to x आएगा ना, और यहाँ पे दूसरा कुछ टर्म है नहीं, इट मींस दैट c2 is 0. ओके,
कॉम्प्लेक्सिटी वाढत
हा
कॉम्प्लेक्सिटी वाढत चालली आहे.
नाही, सोपं व्हायला लागले ते. 1/, नाही फक्त कन्सेप्ट सांगतोय मी, युजली सांगत नाही मी, कन्फ्युजन होतं म्हणून, पण तुम्ही इंजिनियर आहात, माहित असलं पाहिजे. ओके चलो सॉल्व करते, कोई प्रॉब्लेम नहीं, कॉम्प्लेक्सिटी नहीं वाढत, सोपं होत जाते. डी स्क्वेअर माइनस 3d प्लस 2y इक्वल टू 1 e raised to minus x प्लस cos ऑफ 1 प्लस e raised to x. अच्छा, इसको सिंप्लीफाई करो, जो राइट हैंड साइड है उसको सिंप्लीफाई करो आप. सो वी डोंट वांट एनीथिंग इन डिनोमिनेटर, चलो उसको न्यूमरेटर में लेके जाओ. क्या होगा? e raised to एनीवन? अरे काय होईल हे? e raised to, अरे क्या होगा ये? what it will become? e raised to plus x हो जाएगा ना?
Yes, sir.
This is correct. This is okay. Have you understood this? किसी को डाउट है? अरे कुछ आप बोलोगे नहीं तो मुझे भी समझ में नहीं आएगा ना. मदिया,
Yes, sir.
सही है ना?
Yes, sir.
वेरी गुड. तेजस,
Yes, sir.
करेक्ट ना? अरे तेजस काय बोलत नाहीस तू, तुला काही शेअर केलं नाही काय अजून?
Yes, yes.
हा बोल ना.
सर
हा
ई रेज टू मायनस ई रेज टू एक्स येणार ना?
अच्छा, यहाँ पे माइनस लिख दू, यहाँ पे.
हाँ सर.
अच्छा वेरी गुड. ये कुछ नया करते हैं, ऐसा हो गया ये. अरे किधर मैच पड़ा यार, ये दोनों माइनस आएगा ना.
हाँ तेच.
अरे क्या करते हैं आप, ये देखो, से 1 e raised to, we have 1 e raised to a, it will become e raised to minus a ना. now let a equal to e raised to minus x है, हाँ, तो it is 1 e raised to minus x. क्या होगा वो? e raised to minus a पहले मैं लिखता हूं, और ये e raised to a है, वॉट एवर a आई रिटन एज इट इज. ओके, समझो थोड़ा सा मैथ्स. हाँ, ये दोनों माइनस हो जाएंगे, ठीक है. मरिया ध्यान रखना है, चलो कोई प्रॉब्लम नहीं. राइट, जनरल सॉल्यूशन इज y इक्वल टू y ऑफ c प्लस, चलो फास्ट थोड़ा सा भी. हाँ, कॉम्प्लीमेंट्री फंक्शन, auxiliary equation. What is auxiliary equation? d square minus 3d plus 2y नहीं लिखना है. हाँ, so d minus 1 d minus 2 है, so it is d equal to 1 and 2 and therefore complementary function यहाँ पे एक लिखना है. equation number 1 please, you might have written it already. और ये आ गया हमारा, we got the complementary function. अरे you are going through the news of Afghanistan ना? You are reading the news ना?
Yes sir.
Yes, sir.
तो थोड़ा सा whenever we'll get time we'll discuss on that. But one news was there. काफी बार हम ये बोलते हैं कि इंडिया में ये है, वो नहीं है, ये होना चाहिए, वो होना चाहिए, मेरे पास ये होना चाहिए. Usually in our if you leave the concept of India, say in every person's life, we used to think that कि मेरे पास ये नहीं है. Usually we compare ourselves with our friends, our relatives, और बाकी दुनिया में जो सारे लोग हैं उनके साथ usually we used to compare, और ये बोलते रहते हैं कि मेरे पास ये है, वो नहीं है. हाँ, क्या है usually नहीं देखते. हाँ, usually we think in negative way. तो one news was there related to this. One cabinet minister was there, I forget his name, in the previous government. हाँ, तो around before 4 or 5 months he has seen the corruption and everything in the government, and he left the Afghanistan. I think before 4 or 5 months he left the Afghanistan and went to the Germany. अभी जर्मनी में वो काम कर रहे हैं शायद. You might have seen the picture also. It was there in the news for last few days. तो वहां पे वो जाके क्या कर रहे हैं? पिज्जा डिलीवरी कर रहे हैं. He was a minister in the Afghanistan and doing pizza delivery in the Germany. तो आप समझो ऐसे भी हो सकता है लाइफ में. तो आपके पास जो भी है उसमें खुश रहना सीखना चाहिए हमें. It does not mean that कि हमें ये नहीं करना है कि कुछ मिलने के लिए या कुछ पाने के लिए प्रयास नहीं करने. इसका ये मतलब नहीं है. हाँ, लेकिन प्रयास करने के बाद जो भी मिलता है, whatever you get, you should be happy with that. Okay, this is the moral of story. So now we'll go through the moral of our example. So solve करते हैं remaining part. Please let me change the page. Particular integral. चलो थोड़ा सा फास्ट लिखते हैं, कंप्लीट करते हैं. 1 upon d square minus कितना है? 3d plus 2 to be operated on e raised to minus of e raised to minus x plus cos of e raised to minus x. ठीक है, कोई प्रॉब्लम नहीं. So 1 upon we have d minus 2 and d minus 1. What is to be operated first? 1 upon d minus 1 or 1 upon d minus 2? कोई बता सकता है? Can anyone tell me what is to be operated first? 1 upon d minus 2 or 1 upon d minus 1? If I operate 1 upon d minus 2, I'll get e raised to 2x. But that is not in the function f of x. Whereas if I operate 1 upon d minus 1, है ना? इसको मैंने यदि ऑपरेट किया, so I'll get e raised to x, and that is there in the function, right ना? Therefore, I decided to operate, or you will understand these things by practice only, huh? I may tell you n number of tricks, but no doubt they will not help you until you practice it. Okay, तो अभी मैं डायरेक्टली करता हूं. Okay, I'll mention the formula also, no problem. 1 upon d minus m operated on f of x. क्या formula? What the formula is? E raised to mx inside the integral e raised to minus mx f of x dx. हे काय होते? तर काय काय परत लिहायचं? आधीच वेळ कमी आहे. हे यानंतर लेक्चर आहे काय? यू हैव एनी लेक्चर आफ्टर दिस? कुछ लेक्चर है क्या आपका?
हाँ, प्रैक्टिकल है. प्रैक्टिकल.
अच्छा, प्रैक्टिकल है. कितने बजे? 2 बजे? इज इट एट 2?
हो.
अरे बाप, म्हणजे काय तर होणार नाही. ठीक आहे, चला आपण थांबूया. हे तुम्ही ट्राय कराल काय सॉल्व करायचा? आप ट्राय करेंगे इसको? गिव अ ट्राय टू दिस एग्जांपल.
ओके सर.
ठीक है, so I'll not solve this example tomorrow in the class. I'll go through the another example. So please try to solve the example. अभी हम क्या करते हैं? अटेंडेंस लेते हैं.
आंसर सांगा.
आंसर काय? आंसर त्याचा आहे, एकच मिनिट सांगतो. e raised to 2x ओरिजिनल फंक्शन. सिर्फ दोनों फंक्शन के बीच में माइनस है. e raised to 2x into original function e raised to minus of e raised to minus x minus of cos of e raised to minus x. दोनों फंक्शन के बीच में माइनस है, जो कि हमें जो एग्जांपल दिया है, whatever the example is given to us, we have plus sign between these two functions, but in answer there is minus sign. Please go through the example, try to solve it so that you'll understand it. Okay, let me take the attendance. You can see your previous attendance also. कहाँ पे जाना है मुझे? हाँ, यहाँ पे जाना है. I have to stop the recording. Okay.